All right, so it seems the number of participants is now stabilizing, so we're going to go ahead and get started. Welcome to this, the 8th, I believe, could even be the 9th CNCF webinar. For those of you who've been to one of these before, we're mixing it up a bit. Normally there's a couple of speakers and a slide deck, but this time we're going with a panel. And it's all about considerations to be made around cloud-native security. It's a big subject, which is why we've got a whole bunch of panelists. In no particular order of preference, we've got Ben, Diogo, Matthias, Dmitry, Liz, and Christopher. I'm going to let them introduce themselves in a moment. But before we do that, let's get into some rules. There's too many of you on the call to be able to talk live. So if you have questions throughout, drop them into either the Q&A window or the chat window, and I will find opportune moments to interrupt the panelists. Do feel free to aim the questions at specific panelists, and you'll know more about them in a minute when they introduce themselves. And whatever you do, don't wait until the end to ask questions, because then we'll switch off the webinar and you will have lost your opportunity. So let's flip back to the panelists for a second. Should we start at the top with some introductions? Ben, could you say a little bit about who you are?
Yeah, my name is Ben Bernstein. I'm the CEO of Twistlock. Twistlock is the first cloud-native cybersecurity company, and that's about it.
Thank you, Ben. Diogo.
Guess it's my turn. My name is Diogo Monica. I lead the security team at Docker. I think all of you know Docker. We made containers happen.
Nice. Matthias?
Hi there, I'm Matthias Ratestock. I'm the co-founder and CTO of Weaveworks. We have a SaaS product for cloud-native applications, and we're probably also known for WeaveNet, our container networking technology.
Who's up next? Dmitry.
Hello, my name is Dmitry Salin. I'm the CEO and co-founder of Aporeto. We are a startup company on the cloud-native security and not so cloud-native security space.
Very good. And who's left? Oh yeah, Liz.
Hi, I'm Liz Rice. I am technology evangelist with Aqua Security, and we have a product that makes it easy for enterprises to secure their containerized deployments.
Very good. And last but by no means least, Christopher Liliana.
Hey, that's 5 points, Mark, for getting it right. So I'm Christopher Liliana. I am the CTO and co-founder for Tigera and the original architect behind a project called Project Calico. We do networking and policy enforcement for container and other environments. And I've got operational experience in big networks for a long time. So a little bit of an operational experience as well.
Thank you, Christopher. And last, I guess I should include myself. My name is Mark Coleman. I'm here in my capacity as the marketing chairperson for the Cloud Native Computing Foundation. So we're going to jump straight in. We came up with some questions beforehand because we've noticed in the past that attendees are at first a little bit shy, but I'm hoping that'll change as we go through. How to begin? There's so many good ones here. Let's start with a nice generic one, and I'm going to aim it generally at the panel. So do jump in if you've got an answer. What are the top considerations for securing cloud-native applications versus what you might call traditionally built applications? Anybody?
I can jump in with an opening thought on that. I think one of the things that's synonymous with cloud native and containerization is the idea of microservices. And by decomposing a software problem into smaller microservices, it gives us a way to reason about the security in a decomposed way as well. We can look at those individual services and secure those. It's much easier to do that because they are smaller and easier to reason about. And so although the aggregation of the security problem is no more straightforward than in the old-fashioned pre-cloud native world, in some ways that decomposition does help us address security concerns.
Yeah,
I would actually, if I could jump in, build on what Liz said. I think on a cloud native component, the first thing or the major difference between a workload that is running on the cloud and a workload that is a traditional application. And I think it's one of the reasons why we're seeing so many people adopt the cloud, and why we're seeing the FUD around the cloud is insecure disappear completely, is the fact that it gives us one security property that is also a really good property for your infrastructure, which is accountability. By moving to the cloud, now you know which applications are running, where they're running, and what servers, simply because the cloud providers bill you by the second, by the CPU cycle. And so since they want to bill you correctly, and since they want to make money, there is an incentive aligned between the provider that is aligned with the security angle from the actual customer, which is a perfect transparency and accountability of every single thing that you're running. I think that is a really powerful major difference.
I think.
Yeah. Oh, sorry. Go ahead.
Okay, so a little bit off of Liz's point. I think the thing that is interesting, as she says, is we've now decomposed services. It's easier to reason, as Liz said, about what each component does, and those components now are handled automatically. And the rate of so there's an advantage to this, is we now have more discrete, simple components. It's easier potentially to figure out what policies should be applied to them, however you desire to do that. I think the thing that does become maybe a little bit more interesting, a little bit more of a challenge, is these things now are much more dynamic than they were before. These environments are much more dynamic. You have churn rates and volumes of moving pieces in your cloud now of many orders of magnitude more than you did in the classical siloed virtualization world, or even predecessor to that. So I think you do need, you have these capabilities, you have the ability to have very small microservices, easy to reason about, but you have to deal with them being much more dynamic than they were before. I think one of the key things that Cloud Native brings to this is Cloud Native, as a general rule, wraps lots of metadata around all of these components. So you can now start using that metadata that the orchestration system, et cetera, is using to place workloads and scale workloads, et cetera. You can use that to also drive security and policy decisions at the same time that the orchestration platform is actually mutating the environment to meet the current needs. So if you don't leverage that, I think you do end up with a trouble. If you try and build a legacy policy enforcement environment in this space, you will end up with trouble, if for no other reason than the amount of dynamicism that exists in them.
Yeah, this is the whole point about it, is that you eliminated some manual processes that people used to do, and they used to allocate physical servers and then virtual machines, and then you had to open a ticket, an IT ticket, to get this or to get that. And now when all these processes are automated and they could scale down to granularity of microservices, you have to automate the way you actually look into it. You can't use speed bumps anymore for security. So that means that, it starts from hygiene of things that get into production. So before you actually put things into production, you need to automatically inspect them, because you could have done that manually before that. And once they get into production, we were talking about active threat protection, like pre-breach, post-breach, WAFs, anomaly detection, all that types of stuff. Anything that required manual intervention needs to be now updated automatically. So it's basically a game changer. But like you said, a lot of the stuff is already declared. Like there's no setup guide, there's no security guide. It's just the declarative language the developers or the DevOps actually used, and that gives you a way to automate things, which is great. And there's less room for mistakes because there's less manual work.
Right. So I see it actually as three dimensions, right? The three common problems that security teams had is they didn't know what was running out there, so they were trying to guess all the time what to protect. Developers couldn't express what they wanted from security. The interface, the API between developers and security was a spreadsheet, and security was static. And I think Cloud Native helps us across all these dimensions. As the previous people said, is the first one, inventory is just an API away. The developers can now express their intent, and by expressing their intent, security knows what the developers are trying to do, so it can do something educated. And for me, the third is that security itself can become part of the code. So essentially, we are moving to a direction where security policy, security guidelines, whatever is the security posture, if you want, of the organization, will be checked into GitHub together with the rest of the code, right? So I think across all dimensions, cloud native is actually helping us. And it's the best friend of security, I would say.
Thanks, guys. So one thing, I've noticed a couple of attendees using the hand feature. Unfortunately, there's way too many of you for me to keep track of that. So if you've got questions, drop them either in the chat or use the Q&A box. Speaking of the latter, we have a question coming in, which is a little bit meta. How do you guys actually define cloud native?
Well, we should let Diogo answer that one.
Delegated.
Thanks, Ben. It's delegated to me. I think actually Ben hit a really good point, which is declarative infrastructure is one of the biggest components that I have in my mind as one of the biggest components of cloud native. Cloud native means that there's one declaration of how infrastructure is running, such that you can deploy in a cloud environment and it can be set up in a remote infrastructure. It also means that effectively the obvious component is that you're running in third-party services. You're making use of software as a service and shared APIs, and you're definitely deploying, and to Liz's point, microservices, and you have an infrastructure that is definitely composed of multiple independent microservices, and you're following effectively the de facto standard of how applications are being deployed, and which brings us to also service meshes and all these new things that I also put on the cloud native component. This is like the current de facto best practices and standards. This is all what I define as cloud native. But agree that there's a lot of definitions. Agree that there's way too many cooks in the kitchen. Agree that there's a lot of confusion between the containerization, orchestration, and what cloud native actually means. I use it as a catch-all for the current standard best practices of this new generation of orchestrators and containers, microservices, and service meshes.
I like to, it's not a good definition, this is Ben, but I think that the opposite of cloud native is like server native. So anything that's not sort of server native becomes like cloud native, because the whole point is distributed software and things that don't tie themselves to a specific server, and they focus on the application itself. And then that application could be actually orchestrated and executed in this entity that's called the cloud. And I think that's sort of the definition, and it has a lot to do with everything that Diogo just said.
I think the highly dynamic nature that was brought up in the previous question, and just the sheer scale, the number of types of components and then specific instances, and how quickly that the system can change over time. That's also sort of a new, unique angle on that is kind of specific to cloud native, I think.
Yeah, I think, from my perspective, it really does, as Diogo mentioned, it's this declarative model, and your infrastructure is now code, right? You're not raising a ticket with the IT team, the storage team, to get a set of a block volume assigned to you, etc. And we ended up coming down this road a little bit. I noticed the question mentioned AWS. As people started leveraging third-party services for what had inherently been pieces of infrastructure before, S3 buckets or whatever else, they started needing to write infrastructure hooks into their code. Cloud native is just the evolution of that, where I now have to be declarative about the things I'm going to use, because I may not even be in an environment where I control those, or even my company controls those. So I have to be declarative about them, and that's really turned us into a declarative-based, metadata-driven environment, and that's cloud native. And it doesn't mean it's all containers. You can bring legacy workloads into this environment, and you can attach the same kind of declarations and metadata to them. It just means that might be harder, because some of those things might be bigger and messier and more difficult to wrap your hands around as far as what to declare. But there's, this doesn't necessarily just mean containers. It can mean serverless. It can mean VMs. It can mean bare metal even in this environment. It's, it's not a specific type of containerization or virtualization.
So David, who actually asked the original question, retorts with, so wouldn't containers that are in essence servers not be cloud native? I'm viewing it more as serverless versus servers. Having a declaration of your infrastructure doesn't necessarily mean you secure it any differently than you would traditional servers, he argues.
I said that it's, so I just feel like comply to say no, containers are not in essence servers as far as I know. Containers are actually workloads that are server agnostic. I mean, serverless is one way to do it. Containers is a different way. If you're using orchestration, your containers are not tied to a certain server. So that's the whole point of them. They're serverless in that essence. I mean, so I object to saying that containers are in essence servers. I don't think so.
And I would jump in and say, go ahead, Liz.
Oh, yeah, no, I was just going to say that, you know, containers are really not the same as servers, and they're not the same as virtual machines. You do have a different level of isolation there. That means you do want to be looking at native security solutions. You know, if you're running, for example, some kind of vulnerability inside a container and that gets exploited, you don't then have the protection of VM isolation to help you. So you do have to approach this from a kind of a container. If you're talking about containers, you need to be thinking about container specific security. You can't just sort of assume that everything is, you know, just on the host, or that a container has the same security primitive setup as a server does.
And jumping in, I think that there's something to be said for on the containers side of things and on the declarative infrastructure as code side of things. There's something to be said that fundamentally changes security, which is if you have a declarative way, or if you declared pre-hand what your infrastructure is supposed to run, you have effectively a map of what should be running where. And if you tie this together with the immutability components that containers in these new generations of tools give you, this completely changes the game for security. You have immutable infrastructure, you understand what the expected state is, and it becomes a lot easier for you to effectively have a diff between the current state of your infrastructure and the expected state. And it also means that your security team does not have to inspect necessarily or constantly the current state. It should have that component, but it can reason about the security of the architecture. It can reason about the flows. It can reason about the exposure of applications by literally just reading files that describe what are going to be open to the outside, what ports are exposed in a load balancer, what services are connected to each other. It can actually draw flow maps just from YAML files itself to understand what the flow is supposed to be. And then, yes, absolutely, there should be a component that at runtime, in reality, verifies that these are the expected results. But the security team can design, can architect, can understand where things are supposed to go, whereas before we didn't have that. So this is a game changer for us.
I think, you know, just to clarify, I wasn't saying that servers are like containers. What the point I was trying to get across is in any environment you have a number of different environments. You know, nothing's ever really truly greenfield. You can now bring some of those things into a cloud native environment, introduce them at some level. But the idea is not to base things around servers, to base things around workloads, wherever those workloads happen to be executing, and having metadata that drive them. If you try and secure this, the question, if you try and secure this the way you secured things before, where you raised firewall tickets, and now I have to get another IP address put into the firewall to allow a specific thing, that may work if you're running a purely server environment and you push configs to those servers every couple of weeks. People are now burning down servers, look at packet in orders of minutes or hours. So all of a sudden that becomes problematic even with servers. And if you do have containers and the world is moving toward a more modularized microservice-based environment, those things last seconds, minutes, maybe hours. If you do that with raising firewall tickets versus via email, you're not going to be successful. You know, I've heard from a lot of our customers who say, you know, we can stand up workloads in 2 minutes and it takes a day and a half to get the firewalls updated. And that's a fail. So you can't, even if you are using servers or VMs in your cloud native environment alongside containers or serverless, you still have to come up with a different way of securing it, because you're not going to be able to meet the demands of the business or your infrastructure by doing this, by passing emails around asking for firewalls to be updated or load balancers to be changed. That's got to be done as part of the orchestration environment automatically, based on the metadata and the declarative environment.
Back to your point though about VMs, and back to Diogo's point, I think that anyone who's just taking, you know, workloads, traditional workloads, and just put something huge on a container like a SharePoint, I'm just saying, like putting a SharePoint VM on a container and spinning it off, opening all the ports and thinking that he's going to get more secure with that, probably not, you know, he hasn't done himself a good service, I think.
He's probably done himself a worse service than leaving it where it was.
Because he's probably not declared, you know, his declarative language is probably not describing it very well, because he doesn't know what that SharePoint is doing. So he can't take advantage of a lot of these things. And so, and also, like, there's no microservices. He can't sort of keep checking what he's pushing into production. Like, he's probably doing himself more damage than if you would have kept it in the first place. So even though VMs, you could claim that VMs could be cloud native, if you're not using microservices, you're not using declarative language, you're not using CI/CD, then you're fooling yourself with that, and you probably won't get all the good stuff that you can do with it, including security.
Completely agree.
So I'm going to jump in here because the original, and we're going to leave this thread after this next question, I think, because there's a lot to get through. But David says, fair. I'm going to do his voice for you. I'm going to imagine he's exasperated. Fair enough, Ben. I guess it depends more on what type of workload you're running. But for example, if you're running a simple web API server as a container, how does that change anything as to how you would protect the service? I'm not saying that having a declarative infrastructure isn't good. Believe me, I love metadata, he says.
So I hope I understand the question right, but just the fact that you're running, say, like you're running a REST API. So the good thing is that with declarative language, you could know exactly what's supposed to run. So you know which processes are supposed to run. You could probably know which system calls are supposed to run. You could probably know if it's running on an Apache, you know that this processes should be using, you know exactly where the configuration sits. You could automatically know that only this process should only listen to that port. There's a lot of things that you can lock down that traditional security didn't give you the advantage of doing. So, you know, if you look at traditional security, when you're trying to secure application against breaches, you were typically looking at blacklisting. You're thinking about how typical attack patterns looks like, and here you could basically just see if the container is actually doing what it's supposed to do or not doing what it's supposed to do. So that gives you a lot of advantages, and this is just by learning what the declarative language looked like. But even if you skip the declarative language, just the fact that it's minimalistic could actually help you apply. You know, machine learning is a hot topic right now, but what we're doing, or what you could do, is you can apply machine learning to these elements, and you could, there's much more signals than noise when you start working on microservices. And so once you start breaking it into different REST APIs, you know, some of the concept like microsegmentation, nanosegmentation that used to require an admin working very hard on doing, now you could actually do that automatically, and that gives you a lot of power of them. Anyway.
I think building as well on the just building as well on that, the concept of immutability that I think Diogo mentioned earlier. If you deploy that web server, you know, as an example, inside a container, not only can you sort of minimize the set of activities that are supposed to happen, you know, like Ben was talking about, you know, only opening certain network ports, but you also can restrict access. Like, there's no reason to SSH into that. Cloud native sort of processes tend to lead towards immutable code. There's no reason for anybody to be directly getting into that container or even getting into the VM and changing the executables available on that server. It should all be automated these days. And that does give you a different level of protection in terms of the software that's being deployed. It's all automated. You should have a very clear record of what's being deployed into your cluster.
And in classic security, there's something called indication of compromise, and it's blacklisting. What Liz just described helps us actually generate indication of compromise. Like, you look at all the indication of compromise and you're trying to say, okay, these are events and I'm trying to extract an alert out of it. So you get much more granular level of what's supposed to be an indication of compromise. So it doesn't mean that, just like Liz said, it doesn't mean that any person that logged into the machine like it's the end of the world. But if you see a person logging into the machine, or you see processes that were not part of interactive session, that's a bad sign. If you see someone's logging into the machine, maybe that's totally fine. Maybe that's a configuration drift that isn't a good thing, but it's probably not an attack. But anyway, all that mass of information allows you to generate much better and realistic alerts than you would get in traditional security software, where they're traditionally either too noisy or too not noisy, actually.
Actually, building on that a little bit, I think one big benefit of the immutability also is you can actually kill your web server every 5 seconds and it doesn't matter, right? In a lot of these web API servers, you can kill it every 5 seconds, so an attacker has very little time that they can do anything. And that actually takes us to the other benefits and the convolution we're going to see, because in my mind, I include the whole idea of the Lambda functions in the cloud native definition, where there your lifetime becomes milliseconds. And the possibility of an attacker attacking a Lambda function is like pretty much next to impossible, right? So the immutability of the component, whether it's a whole web server or whether it's actually a Lambda function, pretty much allows you to make this dispensable, right? Kill it every 5 seconds.
I would be very careful about killing my servers every 5 seconds, and also attackers are kind of smart. So they have, like, after you realize that you get disconnected every 5 seconds, so you just make sure you continue, you continue looking at what you're exploring it. Like, there's an attacker at the other side, so he can look at that side and that side, like the persistency is in his mind, not in the server necessarily. So there are ways to work around that. I wouldn't use that as the first layer of defense.
What I would like to maybe level us a little differently, we're always talking, we talk about security, everyone thinks about hackers, et cetera, and that's definitely something that, we're talking about here and how you secure it. Security is also availability. So I'll put my old operator hat back on from running a really big network. I hated people SSHing into routers, because inevitably someone in the NOC would SSH into the router and change something, and then that router is a snowflake. It's different from any other element in the network, and its behavior is different. If you take, that was bad enough, so we always want everything to go in through configs, and you push the configs down if you need to make a change, and it's a general push. If you do that now in a cloud native environment where things are automatically scaling, et cetera, if all of a sudden you have a snowflake because someone SSH'd into a container to fix a problem and they fixed it on that one and they didn't fix it on anything else, all of a sudden you have one snowflake in your load balancing environment that behaves differently. Try and troubleshoot that when 1 out of every 1,000 queries goes bad because you've got a snowflake there. The immutability is really, really important here, because the system at a higher level, the orchestrator, is firing these things up and scaling them up and scaling them down. And if you have things that are snowflakes, even unintentionally in here, you're going to have availability problems at the bare minimum. So, don't do that. I guess, immutability is there for a reason, and it's a really important reason in these kind of environments.
Thanks, everyone. I'm gonna stop that there, because we've been going in the same direction for a while. I want to take a slightly different look. David says, thank you for your answers, by the way. So you've satiated his desire for knowledge. Now, there's a couple of questions coming in which look like they're from 4chan, so I'm going to ignore those for a minute. Let's take a slightly different tack here. Brad asks, and it's about 6 sentences in one, so I'm going to try and paraphrase. How do we address the growing gap between recent fast-moving cloud-native infrastructure patterns/tools and the ability for the vast majority of traditional SOC or security teams to reason about the systems that they are increasingly not aware of? I think the question could be put as, how do we deal with the fact that some of the teams within the organization will be doing all this new kind of stuff, and the rest of the organization is going to be doing old stuff, and we still got the same team in the middle trying to manage everything? Brad, if that's not what you meant, put another question in.
I think that's actually a very good question. There was a good comment actually by this guy, Jeremiah Gosman. He's an AppSec guy the other day that said 90% of the security innovation is going to the new applications, to the new things, and 90% of the security problems are actually in all the legacy infrastructure. And we are not doing much to solve these problems. And I think that's a you know, if I look at it as a security operations team, right, what is the percentage of the workloads in a large enterprise that are actually cloud native, or they have moved to containers and microservices and so on, and how many of the other stuff do I have, and when am I going to move my databases to cloud native, when am I going to move my Hadoop clusters to cloud native, or whatever this component is, right? And I think we cannot see security just in isolation, right? By just solving the problem within the cloud native environment, I don't think we can address the real problems that the operations people are facing. So it is definitely a gap. And the only way to gradually move it, it's going to be a gradual transition. It's going to be a transition by giving the tools to people to integrate between the two.
I think I would jump in and be a little controversial. I think this is absolutely right. I think Dmitry is right. I think, and Jeremiah is amazing, and he's absolutely right. 90% vulnerabilities aren't the old thing, the Java application that hasn't been touched for 25 years, that still has to be deployed in the infrastructure, whatever it is. However, I feel like as engineers, number one, we really like shiny new things. So we really like only working on the new stuff. Number two, we're always of the mind that the new version will solve this and the new infrastructure will solve this. And why would I dedicate time to the old stuff when the new stuff is so much better? But to be fair, one of the reasons why I personally, obviously, am investing in this area, and why we try at Docker a lot to do modernizing traditional applications and putting them in containers, and so help old or legacy applications move to the cloud. That's like some of our focus. The reason for this is that we have 25 years of failing at security of the normal infrastructure. So there's no hope that there's some new vendor that comes in 2017 and says they're going to fix the same problems of the same infrastructures, when we've had all the other vendors and all the other engineers failing so consistently for the past 25 to 30 years. And so it's just like this unreasonable expectation that just because people are putting ML and AI, like Ben said, on their slide decks, that companies will somehow, without any difference, go back to the old legacy applications and secure them. And I feel like the hope of all of us in this webinar is the fact that as people move to these new components, they move to these new systems and these new ways of thinking that have core advantages on the immutability, on the actual transparency, visibility, so on and so forth, that we finally have the opportunity to start winning instead of continuing losing. And I'm going to be the first, like Equifax.
There it goes.
So wait a minute, just before we jump in again.
Yeah,
because
one
Brad
second.
Brad has clarified his question. So just let me, it's along the same lines, but Brad has clarified his question. So I just want to, so he's basically asking, he says, if traditional SOC teams aren't up to speed on all the cool new stuff, how can they add value if other people in the organization are using Docker, Kubernetes, etc.? How can they respond to attacks if they don't know how to reason about the systems they run in? In other words, if we leave them behind, aren't we decreasing our ability to respond correctly during a compromise? Which I mean, is pretty much the same question, but a little bit.
It is. So, and this is something, we actually have been working with a lot of folks who have the legacy new environment stuff. And I think part of this is just getting the SOC teams to understand, or whatever teams, classical operations teams, et cetera, understand that things now are really driven by, in this environment, are really driven by policy. You don't write firewall rules anymore, right? Managing firewall rules and IP address lists is pretty much useless. And guess what? They're as frustrated dealing with that kind of stuff as we have been, because they've been taking it on the head for the last 10 years on why they can't get the firewall rules to match, or gee, is that firewall rule that's been there for 5 years even valid anymore? If you point out that what you now need to think about is in terms of policy, what should be able to talk to what? Things that do this should be able to, things that do this should have this kind of communications path. Once they get that, they actually usually come on board because they realize that that's going to make their life somewhat easier. They understand how this works in the new world, that now if they need to do something, a new corporate policy, it is a policy statement, not trying to figure out how to distill it into Cisco ACL rules. And then they start looking for ways of bringing that kind of technology back into the legacy side. And there's many different ways of doing that. But once they see that this can be done as a policy-driven model, rather than based on things you infer based on IP addresses, etc. They usually sort of come along with it, but it is a bit of an education to get them to start. Well, you get the one I love is you get people come and say, how do I convert these firewall rules into this new cloud native environment? It's like, well, the first thing is you don't, because those IP addresses are now ephemeral. Forget about that. We need to think about different ways of dealing with this. But you do have to bring them all along on a journey.
I think I would just add a bit of a cautionary note on policies. I mean, I believe policies are definitely the way to go, but also historically, there have been many cases of unintended consequences, right? If it's very easy to change some fairly abstract policy without actually understanding what the applications are, what the implications are of that. And similarly, I think that's also obviously a kind of the burden of proof on the security vendors that those policies that you have defined actually in reality also get enforced, right? And you're going to have to convince your security team that all this new wonderful.
I understood the question a little bit differently, and I think there's a lot of security tools today in the cloud era that start with discoverability. I mean, that became sort of like a core thing. When you looked at CASB, like the cloud something solution broker, like folks like Adalom and I don't know, some of the other security companies out there that did it. The most popular thing they did, they called it shadow IT, and they were you'd go to a company and you ask them, do you know how many cloud services you're using? And the company would pick a number, and then it'll be hundreds, because suddenly the IT team realized, or the security team realized, they're using much more than they thought they did. Now, I think in the cloud era, what you're looking for in a security solution is something that could plug into, or your security architecture, something that could plug into your cloud and discover for you what's actually happening there, and give you sort of a report, obviously an ongoing report, but you want to make sure you're not missing, because just like we described, there's a shorter path between someone thinking, hey, I'll put an SSH daemon in production, and actually getting into production, or spinning off, hey, I got the AWS credentials, I'll just start another VM and do something, and oh, I forgot about it. And so you should be searching for in your solution architecture is a way for, or you should put discoverability as one of the pillars that.
I actually think that Brad is making a very good point here, that about the security operations teams, and we have seen that both in the server world and in the network world, and it's a skills issue, and it's a little bit of a mentality issue. Server administrators had to become programmers, network administrators had to become programmers, and we are reaching the point now that security operations people have to become programmers. The traditional method of basing themselves on using yet another UI from yet another security vendor to do security operations doesn't make sense anymore. And I think that's the skills gap that a lot of enterprises are facing, and Brad is right on this, on pointing this out, that there is a fundamental skills gap, a knowledge gap between where people were and where they have to go.
I agree.
Good, Liz.
Go ahead, Liz.
I think Brad is absolutely right about that, the skills gap and the need to sort of educate security teams. But a big part of this, and a big part of the move to cloud native, is automation. It's about continuous integration and continuous deployment. And it means that we can automate a whole bunch of the security concerns much earlier in the process. There's no getting away from educating the security teams about this. But one of the good things about moving to cloud native is, as well, a security team can naively sort of think, oh no, my developers are just going to be throwing me all these containers and I don't know what the containers have in them. But the reality is, tools can be built into that process. Developers can take more responsibility for security. They can be helping their security teams. It's not going to happen overnight. There's a cultural change there where developers are no longer just throwing code over the wall and having a security team deal with all the issues around security. It becomes a much more continuous process.
Thanks, Liz. Thanks, all. There's a whole bunch of questions coming through. So, by the way, if I'm not choosing your question, it's not because I don't like you, it's because it doesn't flow nicely, and I'll try and get back to them all before the end of the hour. I'm going to go there. We have an Equifax question. So an anonymous attendee asks, we've had a number of very high-profile data breaches recently. Equifax comes to mind. Could, or I guess how could, Docker and/or cloud native infrastructure have helped here? And I think I want to add a bit. Where wouldn't it have helped?
Okay, so I'll jump in first. So would not have helped with specifically remote code execution on an application that allows somebody to extract a password from the database from memory, and then the database from being dumped to the outside. If this, assuming, and this is a big assumption, if this was their infrastructure, if they literally got their database connected to a front-end server that was directly exposed to the internet, then that we could not have done anything about in terms of specifically Docker and cloud native. And I think Ben and Liz can talk a little bit about like the intrusion detection system components, and that will help a little bit. But what would have helped, number one, if it required any kind of lateral movement, so remote code execution on this front-end server that was running Apache struts, and it required any kind of inspection. The fact that it's inside of a container is by default means that it's more isolated. It does not have access to the file system of the host itself. It is limited in nature, has a limited number of system calls. If required any kind of escalation of privilege, it is limited in nature. If required any kind of attack on the sidelines on the network, it is limited in nature by just the virtue of being inside of a Docker container. If the Docker container was running as a read-only file system, it would have been really, really hard for an attacker to actually download the normal tool sets and compile them and just continue doing lateral movement and inspection, scanning, so on and so forth. And the fact that it is inside of a Docker container means that it is more inspectable, and that you have access to all of these new applications. And we have both Twistlock and Equisec represented that will for sure jump on the opportunity to talk about this, that allows them to actually monitor the system calls that are happening and detect weird patterns of behavior of these applications. And so the actual answer is that it would have helped a lot if they had an infrastructure that was following these best practices, that was deployed inside of containers, that had minimal least privilege containers and images, and did not really allow attackers to have just free range over the network. It would not have helped exactly if the attacker is just extracting passwords from memory and directly accessing the database and just exfiltrating that. But it would have helped immensely.
I have two where it helps and one where it doesn't, and I'll build off of what we just heard, which was pretty spot on. One, once we go to microservices, you get a couple of benefits which would have helped here. I believe. One is you can implement more of a zero trust model. You know, very often someone finds the vulnerable server, the vulnerable component of your environment. Once they get in there, they're within the trust boundary. They're within the perimeter, and they can go on a hunting expedition and spend as much time as they want, find the interesting bits, and then exfiltrate it out. If you now know, if you split these things up in microservices, and I know that this thing shouldn't be able to talk to these things, you can actually enforce rules and policies and say it shouldn't talk to anything else, right? So it now becomes much harder to do the crawl through the infrastructure to find the interesting bits, right? So you now can scope these things to very limited environments in a really a zero trust model. You don't only want to protect the container from everything else or the workload from everything else. You want to protect everything else from that workload. Assume those workloads are going to go bad, and you want to constrain what they can do. That's one benefit. Two, people don't patch very often because the thing that they're trying to patch is big and complicated, and they don't know what all that patch is going to affect. If you've distilled your services down into more manageable components, and this thing is just a front-end load balancer, it's just acting as a web server, et cetera, it becomes easier to patch. And because it's immutable, you can, in an orchestrated environment, you can just say, okay, I'm going to roll a new version of Apache with this patch applied, and I'm going to tell the orchestration system to start deploying that and retiring the old version. It becomes much easier to patch and keep up with security events, rather than somebody going, oh, I have to go touch that thing no one's touched in 2 years and see if I'm going to break anything when I patch it. You can deploy it as a test cluster and run it against 5% of your traffic and see if it breaks. If it breaks, you know, try again, or then push it into general population. The one thing that it's not going to, or we're not going to protect here, is in Equifax, there's no one, bingo, is a perfect example of it, is the things like social engineering. We can't fix that. You know, somebody registering a site to collect, you know, the company registering a site to collect sensitive data outside of their domain, outside of their direct control, to have people register rather than registering that within Equifax's domain. That's, you know, if you do things like that, technology can't help you, right? There's a certain amount of general security awareness that has to exist in an organization. Otherwise, all the tools that all of us here can give you are for naught.
I actually think that one of the things that a full cloud native, if you want vision, would achieve is moving security up to the application semantics. I think even to Diogo's point, right, if somebody can do a remote code execution and then you can go access the database and exfiltrate data, then you know you cannot solve anything. I think if security would move up to the application semantics and not just, you know, if I'm at the network, I see packets, right? Packets don't mean much. If I'm at the system call, I see system calls, everybody opens a socket, doesn't mean much. When security moves at the application semantics, and then we know what is the API that is actually being driven there, what are the semantics of the API that is actually being called, or what is the sequence of the APIs and so on, right? As we move security up at the application semantics, I think we have the opportunity to potentially do a more forceful control, even for something like this remote execution. But having said that, that is challenging, right? That is challenging because it expects that it would expect from developers not only to declare their intent about the infrastructure, but declare also their intent about the application semantics. But I think ultimately, if we really want to solve the security problem, we have to capture the application semantics into the equation.
I want to give, like, because they asked specifically about Equifax, like, so the security solution available today, and I'm representing in Twistlock. So, but they would obviously solve this because, like, first of all, you got like cloud native WAF. So if there's a vulnerable, you know, actually before going into that, like, if you install today a security solution that looks at cloud native, you get like a big sign saying like, you idiot, you have like something unpatched that is basically facing the internet. Okay, so that's very simple and you patch it. But if you miss that sign, you still get automatically, again, you get stuff that automatically extracts the information of what's actually running and then protects it accordingly. So you have cloud native WAF that will actually block known attacks against that. But if it's an unknown attack, which wasn't the case with Equifax, when you actually inject the shellcode, like the shellcode, and someone tries to spin off a shell, that shell wouldn't go up because you know that that shell shouldn't have run in the first place. So there are about like 3-4 different ways in which you could have first prevented it, and then if the attack would actually happen, it would actually be blocked. And all of that happens automatically. You don't need a person who might have forgotten to configure the WAF or might have forgotten to configure the east-west firewall. And you could actually, if it's a known vulnerability, which is at that time, I'm not sure when that server was deployed, but if it was already deployed, you get like a big sign saying like, stop doing what you're doing. And like you should actually patch this because it's running and it's internet facing. But if it was even something that someone pushed into production, you can actually block it at the CI/CD level. So someone's using some CI/CD, say Jenkins, a developer trying to push an update because now he's updating the software or something, and then he gets back, say, hey, you can't push that into production. It contains a vulnerability, and that's not according to our company's policy. So there's so many things already existing today that would have stopped that. That's it, really.
So there's another question.
Absolutely.
Sorry, Liz, go ahead.
Yeah, no, absolutely. I think, you know, that these policy rules, whether they're network-based, whether they're based on which executables can run, which user IDs can run, these things are really powerful tools that can prevent, you know, they're not going to prevent every single possible zero-day exploit, but they can protect against zero-day exploits. You know, so there is some really sophisticated tooling out there. You know, if the profiles are set up correctly, something that behaves out of the ordinary can be detected. And like Ben said, you know, you'll get big warnings about things that are already known exploits.
So we've had We've answered 16 questions so far. We're doing great. We've got about 9 minutes left. There's a good one. Unfortunately, it's anonymous. So I don't know who asked it, but it's a fantastic question. We've been speaking a lot about technology, tooling. The question is, as immutability and faster CD pipelines allow us to get fixes out quicker, it also means that we're pushing more potentially broken stuff out quicker too. What organizational changes are required to address these challenges?
I think, well, I guess I'll go first. Organizational changes, I mean, let's use buzzword DevOpsy, right? So if you have a DevOps process and you actually have a structure that allows you to move fast and you're continuously having integration tests and unit tests, and you have CI/CD pipelines that are structured, and you have artifact generations that are scanned, and then you have a deployment procedure that is known, and you have this sequence of events that happens all the time, and you actually optimize this process and optimize the way that developers and ops people are integrating with each other, and the handoff, where does it happen? That moment you can deploy means that you can deploy a lot faster to production. And yes, you can deploy a lot faster to production, and therefore the number of issues that you can deploy to production are larger, but your ability to fix them and to actually patch them, and your visibility of the process, and your ability to go back and switch it and kind of like actually have a process that is standard to fix the next vulnerability is actually in itself a really good security tool, and something that very, very few people have in terms of legacy applications, and something that people should try to aim for. So do not think of it as I can no longer control the pipeline. What you have to think of is I have to create systems in the pipeline that allow me to detect these vulnerabilities and these issues automatically. And then once I have the pipeline established, it's all advantages because I can move a lot faster to fix things that then I find, unfortunately, in production and that go through to the pipeline unchecked.
I mean, I think I agree that it's the CI/CD change, the automation of testing, be that for function or be that for security. I think the other thing, as we've talked about, is infrastructure is code. And you know, we've made a point, Dmitry, I think, made a point of operations teams and the infrastructure teams now need to become coders. They don't need to necessarily write huge amounts of code, but they need to follow the same kind of practices. Your infrastructure is now defined by code. So those infrastructure definitions, be them YAML files or be them some higher level construct, et cetera, need to go through the same kind of CI/CD pipeline. And there's actually a benefit to having the entire company starting to follow the same process. You know, I do a new release for a policy in the infrastructure because we got some new HIPAA requirements. That goes through the same process, the same review process, the same automated testing process, et cetera, as someone pushing a new piece of code. So I think if what this drives is eventually the whole organization taking this more, you call it agile or CI/CD chain or DevOpsy kind of chain, but everyone starts thinking about the problem in the same way versus someone thinking about, versus infrastructure teams thinking about it very different than the way software engineering teams have done, and legacy software engineering teams thinking about it very different than new generation software engineering teams have done in the past. You know,
yeah, so
you need to follow the same mechanism across the entire organization.
Yeah, so we've coined this term, you know, GitOps, right? It is new world, right? If your entire organization it takes this declarative model and really rapid deployment through version control with audit trail, etc. seriously, then you're in a much better position to quickly detect when something is wrong and respond to it. Right? So.
And as a security person, you must make friends with the DevOps or cloud teams more than you did in the past. I mean, like, used to be friendly with the network team, with the team that used to do all sort of that stuff. Like, your solution, if they're not going to be vetted by the DevOps team, they're out of there. So, or they're not going to use it. So, you as a security person, when you think about the organization, you must buy lunch to the cloud people starting now.
Lunch or liquid?
I'm gonna tweet that, and you must buy lunch to the.
So what we're saying is that one of the central tenets of cloud native is being friendly to coworkers. I can get behind that.
It actually is, but yeah.
So that I think we should stop there because there's a couple more questions, but we're not going to have time in the next 3.5 minutes to get into any serious answers there, unless anyone wants to jump in on that last question as a last comment. No, great. Okay, thank you very much. If I didn't get to your question, or if it's one of the ones that I kind of ignored because it didn't fit in, I apologize for that. I realize now that I neglected to put in the Twitter details of all the speakers there. If you drop me an email at webinars@cncf.io with any follow-up questions, I'll be happy to forward them, but I don't know if they will get answered or not. So we'll have to find out in the moment. I'd like to say a huge thank you to the speakers. Thank you. And a huge thank you to...
Thank you for having us.
Yes, well, it's...
Thank you for putting this together, Mark.
Thank you for sitting and listening to us pontificate for the last hour.
Yeah, and thank you for all the attendees. We had a great number of people showing up, and I hardly had to ask any of my own questions, so thank you very much for the questions as well. That's all we've got time for right now. Thank you very much, and bye-bye.